So what's been seen is that with a good significance, so certainly way within the errors of the measurement, as the errors are understood, it seems like they travel from Cern to the Gran Sasso laboratory in Italy and back again, well, just actually one way, I should say, faster than the speed of light, right? So that's what the measurement says. Now, the reason everyone's cautious is because Einstein's theory of special relativity says that nothing can travel faster than the speed of light. And that's the basis of our understanding of physics. And it protects cause and effect in the universe. So the reason you can't build a time machine and go flying around like Doctor Who does into the past, all those things, the reason for that is that the speed of light is protected. It's the universal speed limit. So if you've got something traveling faster than light, then it's the most profound discovery of the last 100 years or more in physics. So it's a very, very big deal. It requires a complete rewriting of our understanding of the universe. With some caveats, which I can point out in a minute. So the key point about this measurement is, if it's right, then it's a profoundly important discovery.
Okay, so what are those caveats that you just described then? What would they be?
Well, the first caveat about the measurement, and it's a great window onto why science is the most successful way of thinking that's ever been developed in human history, which I keep saying, but this is a very good example, is that it's so strange that what the experimenters are saying is we've done our analysis, we've understood our errors as best we can, and our results say that these things are traveling faster than light, so we're going to publish it. And what they're saying is, well, we need it checking because we're very suspicious about this because it's such a strange thing to have discovered. So there are other experiments that find neutrinos around. There's one in Japan and there's one near Chicago. And basically the Cern group is saying, will you please go and check these results? Because we believe them because we've done everything we can. And so we're going to publish it. But it needs checking because it's such an extraordinary claim that it's difficult to believe. I mean, the interesting thing is that there are kind of theories around that might suggest why, if it's true, which actually don't. One of them is extra dimensions. We've talked about this before. Yeah. So the fact that the universe might not have 3 dimensions but might have other ones, and we look for those in different ways at the Large Hadron Collider, and so they're not mainstream theories, but they're fine. But if they're right, then things can take shortcuts through the extra dimensions. So it's just like saying there's a speed limit that stops you going. Let's say you could go from London to Sydney, right? So you fly around the Earth from London to Sydney. Well, the other way to do it is dig a big tunnel straight through the Earth, and that's a shortcut. So in some ways, extra dimensions can behave like that. So what could be happening is the neutrinos could be taking a shortcut through another dimension. Now that doesn't. If some theory like that's right, then you're not really violating Einstein's theory of relativity. You're just saying that his theory is valid in 3 dimensions, or 4 if you put time in there.
So it's like
shortcuts.
So it's like Newtonian physics. It works in certain realms perfectly, but it doesn't explain things like sort of extra dimensions and particle physics and things like that. And so you're saying basically we're going to have the homework checked. We're going to have the homework checked, and if it all checks out and you still get all the red ticks, then basically we all have to go back to the drawing board and we have to sort of start looking at why this happened, and we're going to have to rewrite the book a little bit.
Yeah, and if it's right, I mean, so if it's confirmed, and this is the way that science works, so we go away and do it again, and check, and then do it again and check. If it's confirmed, then it will be the most important discovery in physics in the last at least 100 years.